Okay, so continuing the trig functions from yesterday, as you can see, I drew a right triangle. You can see the right angle here. One angle is a right angle. One angle I labeled X, and the other angle I labeled Y. Okay, so let's do the sine of X, the cosine of X, the sine of Y, and the cosine of Y. Okay, so for X, the opposite is 3. The hypotenuse is 5. And the adjacent is 4. So remember from yesterday, we were using the formula SOHCAHTOA. Okay, so for the sine of X, it's going to be opposite over hypotenuse, right? Opposite over hypotenuse. Okay, and we said the opposite is 3. And we said the hypotenuse is 5. Okay, now for the cosine, that's going to be adjacent over hypotenuse. So we said the adjacent is 4. And the hypotenuse is 5. So we have 3/5 and 4/5. Okay. Now let's do the same thing for Y. Okay. So if we do it as Y being the reference angle, we have to change which one is opposite. Okay. So if we use Y as the angle, opposite is now 4. Right? Because 4 is across from Y. And the adjacent is now 3. And the hypotenuse is still the same. Okay? So for the sine of Y, and I wrote these a little too close together. For the sine of Y, it's going to be opposite over hypotenuse. Okay? But the opposite for Y is not the same as the opposite for X. So now the opposite is 4 because we're looking at angle Y. Okay, so the opposite is now 4 and the hypotenuse is still 5. All right. And for the cosine of Y, that is adjacent over hypotenuse. So the adjacent we said is 3. And the hypotenuse is still 5. So we have 4/5 and 3/5. Now notice that the cosine of X is the same as the sine of Y. And the sine of X is the same as the cosine of Y. Okay, that's because, let me show you real quick. When we first started with X, that made the opposite 3 and the adjacent was 4. Okay, but then when we jump to the other angle, Y, Now the opposite becomes 4 and the adjacent becomes 3. Okay, so it depends on which angle you're doing. All right. So if you have the same triangle, it's always going to work that way. Okay. Now remember that the angles of the triangle, they add up to 180, right? And we have a 90-degree angle right here. So the only angles left other than the 90 are angles X and angles Y. So angle X plus angle Y is going to equal 180 minus 90, right? So X plus Y is just 90 because we already have a 90-degree angle here. So the other two angles left have to add to 90 degrees. All right. And what we did here, it's always going to work that way if the angles add to 90 degrees. So there's two formulas you want to remember for the SAT. All right. So if X plus Y equals 90 degrees, then the sine of X equals the cosine of Y, and the cosine of X equals the sine of Y. Okay, so you want to remember this formula for the SAT. They don't give it to you. All right. And it also works the other way. So you can say if sine of X equals cosine of Y, or cosine of X equals the sine of Y, then X plus Y equals 90 degrees. So you want to memorize that as well. Okay, so those are two important theorems or formulas that you need to memorize. Now, I haven't seen any like this on the SAT, but for this particular con assignment, it also works for the tangent and the cotangent, and it also works for secant and cosecant. Okay, I don't want to make the video too long, so you just trust me on that one. Okay, it's actually an easy con assignment. All right, and I've never seen the SAT problems where you had to know this part of it. Okay, I've only seen the ones where you either need to know that or that with the sine and the cosine. Okay, but just know for the assignment, it also works for the tan and the cotan, and it also works for secant and cosecant. All right, and you'll see that in the assignment coming up.